We don't need new technology in terms of we don't need miracle technologies, but existing technologies can be improved. And these include clean renewable electricity generators and heat generators. If you can stop all emissions today, you will not get new warming. There are 12 states that produce 50 to 120% of their electricity demand from just wind, water, solar. We expect that CO2 would drop to about 350 parts per million by 2100. If you do this electrification,
Mhm.
et cetera, you're reducing your energy needs about, we calculate 54% worldwide. If we electrify everything and provide the electricity from wind, water, solar, our energy costs go down from $17 trillion per year to about $7 trillion per year. People are currently using technologies to produce the pollution that affects people's health and the climate, and those just need to be replaced. In 2024, China built 380 gigawatts of wind, water, and solar. The US is definitely dropping the ball right now in terms of leadership. China, for example, is deploying way faster than the United States right now.
Hello, everyone. Welcome to Science Talk, another episode. I'm your host, Dr. Mohammed Ittifaq. In this episode, I invited Professor Mark Jacobson to talk about his work, clean energy, black carbon, and climate change. Professor Mark, welcome to Science Talk.
Yeah, thanks for having me on.
So, you have written extensively over hundreds of articles on various topics related to climate change and specifically about clean energy. So my first question is, you have written two books almost, if I'm not wrong, about the technology. Do you really believe that technology is going to save our climate?
I believe that, yeah, well, the technology is the only way to save our climate, but we don't need new technology in terms of we don't need miracle technologies, but existing technologies can be improved. And these include clean renewable electricity generators and heat generators, such as wind turbines, solar panels, geothermal uh, electricity through enhanced geothermal and conventional geothermal, existing hydroelectric dams, maybe tidal and wave power to a small degree, but battery technologies, including battery electric vehicles, battery storage, these are all existing technologies. They obviously can be improved, but we need to deploy all these technologies and electric heat pumps as well, electric induction cooktops. Um, Putting energy efficiency is a really big player as well. So using just insulating homes, using more energy efficient appliances, better building codes for adding insulation to buildings and reducing loss from windows. Um, so we don't need miracles. We have technologies that need to be deployed on a large scale and this is being done moderately in some places and pretty aggressively in other places. But yeah, I mean, there's no other option because people are currently using technologies to produce the pollution that affects people's health and the climate, and those just need to be replaced. So yeah, we do need technologies, but not miracle technologies.
So if we have already what we need, because when we talk about technology, these things don't come to mind. It comes to AI and those other computer systems and those things. These technologies, what you just mentioned, they don't come to average person's mind when we think about climate. So if we have all of these things we need, why are we not deploying it?
Well, we are deploying it, some places more than others. I mean, China, for example, is deploying way faster than the United States right now. In fact, 10 times faster. They have so much renewable energy deployed, in fact, that they can power today 55% of the entire United States for all energy purposes in 2050, given the United States 2050 energy demand. So, I mean, just in this year alone, about 440 gigawatts of wind, water, and solar are being deployed in China. That's new. And that's more, to put that in perspective, there are only around 400 gigawatts of nuclear power in the entire world built over the last 60 years. So China has installed in 1 year the peak capacity of all the nuclear plants built worldwide in history. And so that's an incredible growth. And also electric vehicles, electric heat pumps are being deployed on a massive scale. And there are other countries doing this as well. Yeah, I mean, the United States is also growing clean renewable electric technologies, but just the scale is not fast enough. I mean, some places, I mean, there are states that have in the electric power sector have installed quite a bit. South Dakota, for example, in the last year has produced 120% of its demand with just wind, hydro, and solar, wind, water, and solar. And Montana is about 100% wind, water, solar. In fact, there are 12 states now that are 50 to 120% of their demand in the electric power sector has been met in the last year by just wind, water, and solar. And but you know, on average in the US, it's 25%. So we need 75% more, or to get the remaining 75% with wind, water, solar in the US in the electric power sector. But not only that, we need to electrify transportation, buildings, and industry, which means because, well, when we electrify different energy sectors like transportation, let's take transportation. A battery electric vehicle uses one-fourth the energy as a gasoline vehicle to go the same distance, but it's electricity versus the energy in gasoline. And but when you look at across all energy sectors and well, when you look as a function of all the energy demand, if you actually electrify all transportation, we'd reduce our energy demand across all sectors by around 22%. And if we go to electric heat pumps instead of gas heating, we reduce demand another 15%. If we go to electrified industry, we reduce demand another 4 or 5%. And then we can get end use energy efficiency improvements. You know, we can get another 6, 7%. When we add all this up, we can worldwide, in fact, if we electrify all energy, provide the electricity with wind and water and solar, we eliminate end use demand for energy by on the order of 54%. And actually another 10% of that, or 11 or 12% of that is due to the fact that 11 to 12% of all energy worldwide is used to mine, transport, and refine fossil fuels and uranium. And we don't need to do that in a clean, renewable energy world. We don't need to mine fossil fuels for energy or uranium for energy. And so we eliminate all that energy requirement. So when you add that with all the other efficiencies, we get about a 54% reduction of the demand for energy worldwide. So it turns out that if you electrify all energy, we're going to need 54% less energy,
Mhm.
but then all that remainder will be electricity. So we need maybe a little over 2.5 times the electricity we currently have, but overall we'll need much less energy. So, you know, the US, for example, 25% of our electricity is already wind, water, solar. But if you want to electrify all the energy, then we're going to need, you know, 2.5 times as much electricity as currently. So we're only around, you know, 10 to 12% wind, water, solar across all energy sectors. And so we have a long way to go. But the good news is like, you know, just like China is able to ramp up and produce so much clean renewable electricity to power, if you electrify all energy, the US can too. The US has a larger economy than China and the same land area, and the resources are amazing. So it's really a social and political barrier to actually transition. It's not a technical or economic barrier.
Okay, so is the idea that we have enough renewable energy that would reduces the demand, the energy we're producing from fossil fuel sources
Yeah,
automatically. So we will see like what normally is communicated from these fossil fuel companies that we have to rely on these fossil fuel because it's more efficient, it's available, it's not cheap. That argument is gone because renewable is more cheaper now. So is that the idea? There's no kind of demand, that's why there won't be any supply.
well, there is, okay, so the idea again, just to summarize, is to electrify almost all energy
Mhm.
and then provide the electricity from just wind, water, solar, which is, well, we call it wind, water, solar, or WWS. It's a little
WWS, yeah.
acronym. It's very convenient, but it really means onshore and offshore wind,
Mhm.
solar photovoltaics on rooftops and in power plants, concentrated solar to some degree, although that's not doing so well. geothermal electricity and heat, hydroelectricity, and maybe tidal and wave, but it's mostly going to be wind, solar, geothermal, and hydro. And that's all we need. And that's, for the fossil fuel companies to say, oh, it's cheaper for fossil fuels or we need that, that's nonsense. I mean, it doesn't make any sense either because with wind and water and solar, there's zero fuel cost.
Mhm.
I mean, the wind comes right to a turbine, solar comes right to a panel, geothermal heat comes right to, well, you try to bring up water, hot water from underneath the ground, and the heat comes right is by conduction. Usually heat is just transferred naturally, so you don't have to mine for the heat beyond the first initial mine. And then hydro water comes right from precipitation. So you don't need to drill 50,000 new oil and gas wells like we do in Central North America alone each year. Like we have in the US, we have about 1 million active oil and gas wells and 3 million abandoned ones. So you just have to keep drilling forever over larger and larger swaths of land to keep fossil fuels going. So it's just insane for somebody to think that that's cheaper than not having to do any of that drilling
Yeah.
because it doesn't make any sense. So in fact, we look at it is so much cheaper to go to clean renewable energy. I mean, we look at I mentioned there are 12 states
Mhm.
that develop 50 to 120% of their electricity right now. Their demand for electricity are provided by wind, water, solar. Well, 11 of those 12,
In all sectors, or just houses?
well, all their electric demand, not all energy sectors, so not for transportation, buildings, or industry, but all electric power.
Mhm.
So, I mean, when I say not for buildings or industry, it's the electric power for buildings or industry, but not the heat.
Okay.
Okay, so just the electric power sector. So we're talking about grid electricity. There are 12 states that produce 50 to 120% of their electricity demand from just wind, water, solar in the last year. So this is over an entire year from October 1st, 2024 to September 30th, 2025 is a full year. And of those 12 states, 11 have electricity prices at 2 to 5 cents a kilowatt hour below the US average. Only one of those states has electricity prices above the US average. And so it's cheaper. I mean, it's just cheaper to go to wind, water, solar. So it's just the facts on the ground. And it's cleaner because you eliminate the
Yeah.
health and climate costs associated with it. Um, and so you're even if you want to ignore these what are called social costs from health and climate, it's just cheaper for your pocketbook.
Mhm.
And it's more sustainable, and you don't need to continuously drill for oil and gas and build pipeline systems. Um, and it's more reliable because, usually, first of all, there's already storage associated with hydropower. Hydropower is already a big battery. That's the largest source of storage worldwide. Geothermal is baseload by all, virtually all geothermal worldwide is used as baseload electricity, just like nuclear power, but it's a lot easier to install and it's cleaner and cheaper. And wind and solar are intermittent, but now they are coupled with not only the hydropower, but batteries.
Mhm.
And batteries have come down and cost so much that they're just being built on a massive scale. Just in the last 2 years, for example, California has built, now we have like 17 gigawatts in the entire state, including people's homes, but on the grid, in the main grid, there are about 11.2 gigawatts of batteries. That's a peak power. These are 4-hour batteries. And to put that in perspective, the average power on California's main grid is 24 gigawatts. So you've got 11 gigawatts just and two-thirds to 80% have been installed in the last 2 years alone. And that's providing up to 45% or so of the average power for 4 hours, usually after sunset, because California's experienced over like 200, almost 240 days this year where demand supply of wind, water, solar, so mostly solar, but also wind, geothermal, and hydro, has exceeded demand for part of the day
Mm.
for almost 240 days in California this year, usually for it's anywhere from a few minutes to 10 hours, but on average, it's around 3 to 4 hours a day.
But
And
Mhm. Go ahead.
when you have excess wind, water, and solar greater than demand, that excess, a lot of it's stored in batteries, and then those batteries are used at night when the sun goes down,
Mhm.
and that replaces gas. So in the last 2 years, the gas use on California's main grid is down 37% as a result of the growth of utility solar and batteries. And the other phenomena going on is, especially in California and also Nevada, is the demand is going down for electricity in both states. And that's mostly because of the growth of rooftop solar. Rooftop solar, people's residences and commercial buildings, is what's called behind the meter. And people use that electricity from their rooftop solar before they use grid electricity. So when they use that electricity, the demand for grid electricity goes down. And so even though we have more data centers and AI
Yes.
in California, California has the third most data centers, but also by far the most electric vehicles, like 5 times more electric vehicles in the next state. And that's grown in the last year, and data center use has grown. Despite all that growth of AI and data centers, there's actually a 2% drop in demand in the last 2 years in California. Or actually in the last year, it's 2% versus last year, 1.4% versus 2 years ago. And that is because primarily rooftop solar, even though there's been a growth of demand for other uses, rooftop solar has overpowered that and eliminated the excess demand on the main grid. And we know this because the actual output from rooftop solar is about twice as much as the reduction of demand on the grid in the last year. Just in the last year, the change of output on California's main grid, not in all of California, the change of output is almost double the drop in demand on all California's grids in the last year.
So if we go 100% renewable, and that's the idea that we do not emit more CO2 in the atmosphere, but what do we do with the existing one? We have trillions of tons of CO2 in the atmosphere. How do we remove that? Do we have a technology to do that, or do we like that stays up there and in the next phase we don't emit anymore, and that will go where?
Well, when you stop emitting CO2, CO2 comes out of the atmosphere over time, whether you're emitting it or not. But when you're emitting it, then whatever's coming out is being replaced by what you're emitting it and plus some. But when you stop emitting, CO2 starts coming out. I mean, it takes a long time to come out,
Yes.
but if we stopped emitting 100% of CO2 today, we would expect, and right now the CO2 is like 430 parts per million in the atmosphere. I mean, if you did 100% reduction, which is not going to happen, so we're not going to be able to verify that experiment, but we expect that CO2 would drop to about 350 parts per million by 2100. So within 75 years, it'll go down from 430 to 350, maybe 360 parts per million by 2100 because it is removed slowly by the oceans, by growth of biomass due to photosynthesis. Those are the two main mechanisms. And you also get there are other smaller mechanisms, but it's mostly through plants and small amount of animals and or the organic matter on the land that's produced from CO2. But there's also weathering of rocks. Rocks will take it and convert CO2 into rock material directly, but that's slow. And then there's dissolution of the oceans, which is the major removal mechanism.
But some scientists believe that even if we stop burning fossil fuel, the warming will continue after 2100.
Well, the current warming, but not additional warming.
Hmm?
So, like if you stopped all emissions today,
Which is
you will
not
not.
happening, but just imagine the
Yeah,
scenario.
theoretically, yeah, theoretically, if you can stop all emissions today, you will not get new warming. You'll get existing warming, but that will. Okay, so just to put in perspective, what causes the warming?
Hmm?
Well, carbon dioxide is about 46% of warming. Black carbon is a particle component. It's around 16 to 20% of warming. It's the second leading cause. But that has a lifetime in the atmosphere of only a few weeks to months.
Hmm.
So if you stopped all combustion, because black carbon is the main component of soot, and soot comes from diesel exhaust, jet fuel burning, kerosene burning, biomass burning, and some other anything that where you have high temperature flames will produce a lot of black carbon if it's not filtered. And but if you stop those sort of particles, these are different from gases. Carbon dioxide is a gas. Other greenhouse gases are methane, nitrous oxide, chlorofluorocarbons and fluorocarbons or greenhouse gases. These are gases. Uh, Small amount of carbon monoxide to a tiny amount for a tiny amount. Um, and ozone, which is not emitted, but it's produced from other chemicals that are emitted. Those are greenhouse gases that absorb heat radiation from the surface of the earth, and they're transparent for the most part to sunlight. Black carbon is different. It's a particle that is really, particles are made of gases that have changed state to either liquid or solid. In this case, black carbon is solid. It's just pure carbon. And it can be coated by other material. Like when you emit black carbon soot from a diesel exhaust, it's coated by lubricating oil and unburned fuel oil. And anyway, it's black because it absorbs sunlight directly and then it heats up and then it radiates that heat to the air around it. So it actually heats the air directly from sunlight. It also absorbs heat like greenhouse gases, but that's less of an impact. But that black carbon, it's actually absorbing a million times, or it's heating the air a million times more per unit mass than carbon dioxide, which makes it the second leading cause of global warming. The reason it's not just causing huge amounts of warming on a larger scale is the fact that it has a short lifetime in the air, and so there's not as much of it in the air. But the black carbon from, I mean, black carbon is responsible for the extinction of the dinosaurs effectively, because when there's a meteorite hitting the surface of the Earth, that resulted in a lot of ejection into the upper atmosphere, but also the burning of huge amounts of forests and production of huge amounts of black carbon that when the sun hit that black carbon in the upper atmosphere, it heated it up so much that it just created an oven to fry the dinosaurs. So that's just to give you an idea of how, and and
But
also
we don't hear much about black carbon or brown carbon. We only hear most of the time is CO2, carbon dioxide. We don't hear much about black carbon. Why is that? Is it because it's just 14 to 20%, or is it less impact, or why don't we hear much about that?
well, yeah,
Not much
I mean,
debate.
it's more important. Well, and it's doubly important because it not only affects climate, but it also is a strong component of health problems associated with pollution. So it's the second leading cause of global warming, and it's one of the major causes of air pollution death worldwide. I mean, worldwide, there are 7.5 million people who die from air pollution.
Yes, some people say 9 million or something, and 1.6 of them are just in India alone.
Yeah, and so yeah, there's an uncertainty bound, and certainly it could be up to 9 million or 10 million even. But 90% are due to particles,
Mm.
and the rest, due to gases. But the 90 of the particles, I mean, black carbon is maybe could be responsible for like 20% of the particles. There are a lot of other particle components that cause health problems, but black carbon is one of those particle components that creates these millions of deaths. So we do want to focus on black carbon. Well, a long time ago when I was working a lot on black carbon, that was a real focus in terms of policy. Let's do policies that address black carbon because it would slow global warming and also improve people's health. However, I've come to this conclusion more recently. Well, in the last 15 years, I guess is recent. But that, okay, well, we shouldn't be focusing on individual pollutants. We need to really, what's the source of these pollutants? It's combustion. So black carbon and combustion produces black carbon, but it also produces carbon dioxide. It produces, well, you're burning things, so you're mining gas or coal, and they both produce methane when you mine them. So, and there are a lot of other, and then when you produce oxides of nitrogen and hydrogen, sorry, hydrocarbons, and both of those combine to form ozone, another greenhouse gas. So we really want to address combustion. So we want to stop burning things. That's the key to addressing black carbon, carbon dioxide, all the greenhouse gases. So you address health and the other particles that affect health. So if we stop combustion, which is to stop combustion, it's really easy. You electrify everything and provide the electricity from clean renewable sources. That's how we get to wind, water, solar, is by stopping combustion. And so that's the key solution. It's not just focusing on black carbon, let's add a filter to a diesel vehicle, because that just allows everything else to go on. And we don't have time to just focus on one thing or another, like one chemical versus another chemical. We really need to focus on this raw source of the problem, and that's burning fuels. It's not only fossil fuels, by the way, it's biofuels too, and biomass and other bioenergy. Especially in India, I mean, there's a lot of burning of biomass for home
Yes.
heating and cooking, right?
Yeah.
And
And crops too.
crops, yeah, and well, and burning other things too. I mean, uh, the funeral pyres, right? That's the big
Yes.
source of pollution. Um, so yeah, it's burning things is the problem. And the more we recognize that, the more we realize, okay, electricity is actually kind of cool, nifty, and it solves that problem if you can get the electricity from a clean, renewable source.
But this sounds very complicated. All these gases and their impacts on various
Mhm.
things. How do we kind of, make sure that ordinary people understand that this climate is just not the natural environment? It's just the things we are burning, the things we're producing, the things we're consuming. How do we translate that to a layman audience or like people, on the street or somebody who doesn't have, more than eighth grade education to like nitrogen oxide to CO2 to, aerosol and all these. Is it a like, how do we communicate that? Because ordinary person doesn't understand these things related to climate.
Well, yeah, I think then we need to not be talking about these individual chemicals so much and just be talking about, well, when we burn things, we have pollution. So we got to stop burning. There is a solution, electrify. So it's really, from my point of view, it's a really simple solution. Electrify everything and provide the electricity from clean, renewable sources. So
And our economy will be fine.
yeah, well, this is the nice thing because save money from from energy costs. I mean, keep in mind, like you're reducing if you do this electrification,
Mhm.
et cetera, you're reducing your energy needs about, we calculate 54% worldwide. And so even if the cost per unit energy is the same as today, you're using 54% less energy. So that means your actual annual payments for energy are 54% lower. But in fact, the cost per unit energy of wind and water and solar now are they're the cheapest forms of electricity today. When you have new wind or solar. And so the cost per unit energy is also lower too. So we estimate like over 60% reduction in your annual energy costs from transitioning. And on top of that, you eliminate health and climate costs. I mean, just to put in a gross perspective, the world spends today about $11 trillion per year on energy from not only for electricity, but transportation, buildings, industry, et cetera. 11 trillion per year. That's expected to go up to about $17 trillion per year in 2050.
Mhm.
But if we electrify everything and provide the electricity from wind, water, solar, our energy costs go down from $17 trillion per year to about $7 trillion per year.
Oh,
And
wow.
that's because we have 54% less energy needed, and there's a cost per unit energy reduction of another, let's say 15%. And so we get down to save $10 trillion per year. Now, the upfront cost of that transition is about $60 trillion.
Mhm.
That's what we calculate, $60 trillion to transition the world to 100% clean renewable energy and electrify everything. So you take $60 trillion upfront cost, but you're saving $10 trillion per year in energy costs. So that's a 6-year payback time.
Mhm.
But on top of that, you eliminate your health and climate costs. The health costs today are $30 trillion per year,
Mhm.
over 30 trillion. And you can do this calculation easily. I mean, take just be simple. Say it's 7 million people die every year from air pollution. I mean, it could be 9, but let's say it's 7. That based on what's called statistical cost of life, what people value their own life at, it's like each country has their own metric. Like in the United States, each life is valued by the federal government at about 11 or $12 million now.
Mhm.
Okay, so but average worldwide, the numbers are closer, let's say $5 million a person. So to avoid 7 million deaths per year at $5 million a person, that's $35 trillion right there,
Yeah.
right? So that's how you get it's going to be over $30 trillion of health costs avoided. Climate costs will be $30 trillion per year by 2050. Right now they're lower, but
That's almost $100 trillion by 2050. Yeah.
yeah, so you're talking 30, let's just say 30 plus 30 is 60 plus 17 trillion for energy costs. So
Yeah.
that's
It's almost
77
80. Yeah.
trillion dollars per year. and we eliminate the health and climate costs, and our energy costs go down 10 trillion a year. So we go from 70 trillion per year to 7 trillion per year in social costs. So that's a 63 trillion per year savings in social costs. I'm just saying you're saving a lot of money. And then, but on top of that, you're creating jobs. We estimate 28 million more long-term full-time jobs than lost for a transition. We use less land
Mhm.
because we're not continuously mining
Yeah.
for fuels. And we estimate, like right now in the United States, 1.16% of the land area of the US is occupied by the fossil fuel industry. And another 1.24% is occupied by the corn ethanol industry just to grow corn for ethanol for 4% of US transportation energy. So that adds to 2.4% of US land
And
is occupied for energy. If we go to wind, water, solar, that decreases to about 1% of US land. So we use less land, we create jobs, save money, save lives, save the climate.
but do you see the future of flying in a plane powered by solar or something else in next 20, 30, 40 years?
Yeah, so right now we have about 97% of the technologies we need.
Mhm.
And but we do know how to get to the rest. And the rest is like long distance aircraft, long distance ships. And there are short distance aircraft and ships running on electricity, either battery electricity or hydrogen fuel cell electricity. For long distance aircraft, it will probably like a really long distance jumbo jet, for example, that would probably have to be a hydrogen fuel cell electric jet. It can be done. I mean, it's technically feasible. It's in fact, uh, to get a 747 running at the same dist range as a jet fuel plane, you can do it with the same thrust to weight ratio and the same range, but with maybe 20% higher volume, it'll be about 20% less mass as well. So it's been around 20% less mass, 20% larger volume plane can get the same range and thrust to weight ratio as a jet fuel like 747. So that is possible. Whether it's done is, I mean, it won't be, that'll probably be one of the last things to transition. So maybe in the next 10 to 15 years, but 97%, maybe 98% right now of the things we need, we have. And there's a lot we can do right now. And the remaining technologies that aren't here quite yet, like
Well,
there's,
how much these planes emit every day? Because there are thousands of flights all over the world every day. How much do they emit?
well, there are even more than that. There are around 33 million flights worldwide each year. That's just commercial flights, not including military flights. And in terms of greenhouse gas emissions, it's on the order of 2 or 3% of
The
all
total?
the greenhouse gas emissions, but there's also particles that are black carbon particles come out of aircraft too that contribute to warming. And then there's contrails, which have dual effects. Sometimes they warm, sometimes they cool the climate. But imagine though, if you had a battery electric plane, you eliminate not only the emissions of the gases that affect climate and the particles that affect climate, but also those that affect air pollution, but you eliminate the contrails as well.
Mm.
So you have clear skies. Now, if you go to hydrogen fuel cell electric, you reduce your contrails significantly, maybe by 90%. You still have water vapor, but contrails, you need both water vapor and particles from the airplane. So you eliminate the particles from the airplane with hydrogen fuel cells, but you still have water vapor. So you eliminate on the order of 90% of your contrails. But electric airplanes, battery electric, you eliminate 100% of contrails.
And where do you see the nuclear? There's a huge debate about nuclear energy. Do we need that to solve climate?
No, we don't need it, and it won't happen because it takes too long. I mean, if you wanted to do it, it just takes too long and is way too expensive in
But
comparison with other technologies.
They say China is building faster than anyone else.
Yeah, this is a good example of why it won't work because in China, even like in 2024, China built 380 gigawatts of wind, water, and solar, but they completed only 3.9 gigawatts of nuclear. So there's like 100 times the wind, water, solar produced versus nuclear. And even in like the output of all the nuclear plants in the world in 2024 was the same as the output in 2006. So in almost 20 years, there's been no change of nuclear. There's no growth. Despite all what China's doing, they're just all these new reactors that, of course, the new reactors that are being built, they're just replacing retiring reactors. They're not actually growing anything. And their output for the next 10 years, I mean, this year they're building way more wind, water, solar than nuclear that's going to be completed. It's it's just and they're the fastest of any country or the most, but it still takes them 12 to 17 years in China between planning and operation of a nuclear plant.
Yeah.
In
Just
North America and
fine.
Europe, it's 17 to 23 years, so it takes longer, but it's just too slow. I mean, you can't, we need to solve 80% of the climate and pollution problems we face by 2030. So that's, 4 years almost from now, and 100% by 2035. And when you have a technology that you can't even build one reactor in less than 12 years from plan to operation, that's 20, if
Mhm.
we're in 2026, that's going to be 2038 before the
Yeah.
reactor plan today will be finished. That's way past when we need to solve the problem. So
Mhm.
it's not even, it's a non-starter. And these small modular reactors are even worse because they are vaporware. They don't exist commercially. So it's just they're imaginary technologies. I mean, you can build one, but they not commercially. I mean, the military builds some small modular reactors, but they're at the enormous cost is so enormous, but it also takes forever to build. There's no difference between the small and the large, except the small are more expensive because we went to large ones due to economies of scale in the first place. We had small ones in the 1950s and 60s, went to large ones because it's cheaper per unit energy. I mean, you need more concrete, more materials with small reactors. Plus, if you're concerned about weapons proliferation, you'd be really concerned about these small ones because they can be moved around, or the technologies can be moved around as well, just a lot easier. So there's no benefit of these small reactors, even if they're built, but they don't even exist commercially, and they're not expected to be around commercially for at least 10 years, and they won't even be built until much later. So it's like a whole distraction. I mean, we need to focus on what work, keep our eye on the ball, so to
Yeah.
speak.
Yeah, so my second last question to you, do you think like looking at the US landscape right now, US still a very petro state, and China is rapidly growing their, new technologies and phasing out from, not entirely phasing out from fossil fuel, but at least they're developing these technologies, renewable energy, and exporting to the rest of the world. Do you think they are becoming the leader and it's the US fault who created that vacuum to give them free hand, like lead the world with renewable energy?
Yeah, the U.S. is definitely dropping the ball right now in terms of leadership, in terms of transitioning and getting, making our country healthy
Mhm.
and also addressing our energy security in the future. I mean, a reliance on fossil fuels, which is a limited resource that will run out, and just the whole infrastructure that you need to maintain it with pipelines and mines and refineries and all these things to process the fuels when you don't need any of that for clean renewable energy. And then you can see it's all ideology and making money because there are people who are invested in fossil fuels right now who stand to benefit from not doing anything. And so this is unfortunately they give to politicians and they get their back scratched, scratch each other's backs, and they just keep pushing the fossil fuels. Whereas countries that aren't relying don't have this kind of sick
System.
the distraction of
Yeah.
keeping fossil fuels. They're actually moving forward and making real changes for the better for their own countries and for the world. Now, I don't care who builds it all because the key from my point of view is to solve the problems. And
Yeah.
so, if China or other countries want to build all the panels and turbines, I mean, that if that has to happen to solve the problem, then so be
Why
it.
not? Yeah. Yeah. Absolutely.
But
So my
because
last. Mhm. Go ahead.
it's a one-time build out, and then after that, there's a lot of there's maintenance. But it's to get there, we have to do this fast, and whoever's dropping the ball, they're going to lose out. So
So my last question, what is something you think we need to talk more about energy and climate change, and we're not spending as much time as we should be?
You're asking that we're not spending enough time talking about energy and climate change and
Yes,
the
which aspect of it we're not spending as much time as we should be?
well, I don't think we need to talk so much about climate change because a lot of people just tune out when you talk about climate change at this
Yes.
point. We need to focus on solutions and we don't have to focus on the reason for the solutions, except because a lot of people, first of all, like clean renewable energy, even if they don't believe in climate change.
Mhm.
So, for example, creates jobs, energy security, allows people to own their own power, saves them money, reduces their health problems and their family's health problems. So it's fine if you believe in the solution, but don't believe in the problem. I'm okay with that. So,
Well,
not
like, is it possible to do that? Like, even if you don't acknowledge the problem and we agree to the solution?
well, if you're focusing on the solution because it's saving you money, that's
Mhm.
great. Or
Yeah.
if it creates your own personal security of energy security or energy independence. I mean, there are a lot of people who are very conservative who want energy independence. They don't want the government
Yes.
to control their energy.
Yes. Yes.
So that's fine.
Yeah.
If that's what motivates them to go to renewable energy and put rooftop solar on and batteries in their garage, so be it. I'm happy for that.
Yeah. Whatever works for them, for us to convince them to do that, why not, right?
Yeah, yeah.
Yeah.
I don't. It's really the focus. The key. I think the key is to focus on this energy transition, and you can have your own. Everybody can have their own reason why they want to do it, but there are so many reasons that there's somebody can latch on to any one of these five or six reasons to do it. And none of those has to be climate change because I think climate change is the most divisive. And then what I've learned is, I mean, I study climate all the time, but I know that a lot of people just will refuse to accept or believe in climate change. So why try to convince them of that? You don't need to convince them of that
Just go for
because,
the solutions.
well, in fact, there was a public opinion poll. This was several years ago, but it was like 26,000 people in 11 countries were, including the U.S., but a lot of other countries were asked, you know, well, do you believe in renewable energy? Well, first of all, do you believe in climate change? And only 69% strongly believed in climate change. But then 82% though believed in 100% renewable energy. So how do you get 69% believing in climate change, but 82% believing 100% renewable energy? And then they asked the question, well, why is that? And the reasons were because you create jobs,
Mm.
save money, you can own your own power. These are the reasons people gave. It's like they believed in renewable energy because it's something positive and there's not a reason, the only reason you might not want to believe in renewable energy is if you're just tied into fossil fuels. If you're just really stuck with, oh, I have to have my gasoline powered car and
Or a
I
big
like to
truck.
press the
Yeah.
accelerator and hear that noise or whatever.
Yes. Yes. Thank you so much, Professor Mark. Appreciate that coming on the show. It was nice talking.